in sub-Saharan Africa. Lacuna Fund is the world's first collaborative effort aimed at providing data scientists with data sets to ensure that research can be done with available data and credible data, especially in our local communities. HiPIC was among the 6 research groups selected out of over 150 applicants in the 2020 award. They were big players, especially from East Africa and Southern Africa. And by the grace of God, we happen to be the only group from West Africa that was selected. So the award was made by this fund, the Lacuna Fund, to address this issue. Our proposal was titled A Labeled Data Set for an IoT-based Aquaponics Fish Pond Water Monitoring System. So I'm going to describe what we have done between 2020 when this award was given. Why smart farming? When the director ICT was speaking, he gave us an insight to the powers of IoT and IoE. And there's no gainsaying it that in Africa today, the major problem is hunger. The major problem is famine and malnutrition. And of course, if you go to the market today, you know how much, if you go with 1,000 naira, you know how much meat you can buy or fish. And so this project is targeted at providing data set to farmers who will be able to use this data set and the insights from this research to grow fishes and vegetables together. Especially if you live in Nsukka, of course, you know that water is a very costly, what do you call it now? Necessity, basic necessity. I remember last weekend we were struggling to get water. And of course, you know this period, the tanker drivers are the lords. So where you do not have water, how can you grow fishes? And that is what this research is to answer. How can you grow fishes with limited water? And then also, we want to provide knowledge to farmers on the physicochemical properties of the fish water, because the pond, the life of the fish depends on the quality of the water, first of all. So we need to know what qualities are contained in the water and how to monitor these qualities. Like has been said before, aquaponics system combines the conventional aquaculture. Aquaculture means growing fishes, especially in commercial scale. Entrepreneurs, many people are now growing fishes. Unlike before, you have to go to the river and throw your net to catch fish. But now, people grow fishes at the back of their houses. So we are looking at a system that combines both the growing of fishes and plants or vegetables. My colleague will talk more on that, together in a symbiotic way, such that the nutrient coming from the wastewater will be recycled to be used as an input to the plant to grow. And at the same time, it filters the water and takes the water back to the pond, so that you limit the number of times, the amount of time you change the fish water. All right? So through this also, we aim at developing, generating data sets that will be made available to the machine learning researchers, farmers, and others to be able to predict the yield of their fishes and plants as the need may be. So that's what we are here to tell you, So this is the picture of our setup inside the University of Nigeria, precisely in the zoo garden. We set up 12 ponds, 12 mobile ponds, and as you can see the plant bed sitting above the ponds, and then we have a submersible pump inside the fish pond which reticulates the water from the pond into the plant bed. And then we have the IoT devices that we use to get the data in real time. We may not be able to take you to the place, but at the end of this, I'm going to show you a virtual tour. You're going to see a short video of the whole setup. All right. So this is the architecture of the IoT system. Can you project it? The architecture of the IoT system. Here we have a microcontroller. A microcontroller is like a computer in a small chip. Here we used two microcontrollers. At the experimental stage, we used the Udanor Mega, and then for the implementation, we used the ESP32 microcontroller. And then by the side, you will see 6 sensors attached to the microcontroller. You have the pH sensor, nitrate sensor, nitrite, ammonia, turbidity, dissolved oxygen, temperature, and so on and so forth. So this architecture shows that as the data is read from the water, it goes to the cloud repository where it is stored, and it plots it in real time. I will also show us that. So the microcontroller, like I said before, is the ESP32 microcontroller. It has the ability to provide, to connect to Wi-Fi. Any Wi-Fi modem that is present there, we link it to it to send the data to the cloud. By the way, the system I showed you before is powered by a solar unit, so it is on 24/7. So we have solar inverter system that runs the place, so it's always on. So at any point in time, we can check. We don't need to be there. We can stay in any part of the world and look at it. I will also show you how to look at it anytime you want to look at it, and then one of my colleagues will also talk about the data. Okay, so these are, like I mentioned, these are the sensors we used. We have a temperature sensor. This temperature sensor is submersible inside water. You dip inside the water, it takes the temperature, because there is a temperature range of water that fishes will be able to accommodate. If it becomes in the extreme, it will affect their growth. There's turbidity sensor that checks the clarity of the water. Sometimes the water gets dirty as a result of feed and other wastes. And if it becomes too turgid, too dirty, the fishes will find it difficult to survive. They may die. So that's why we have stability sensor. We have also dissolved oxygen sensor that measures the amount of dissolved oxygen inside the water. We have pH sensor that checks the acidity level. If the water is too acidic, the fishes will die. And then we also have gas sensors like ammonia and nitrate. So this is an example of can you show? Yes. This is the temperature sensor. So as it is waterproof, so it's submerged into the water. And then the next one, go to the next page. Yes, this is the turbidity sensor. This works based on the principle of light, the amount of light that passes through it, because it checks clarity. If the water is dark, it limits the amount of light that passes through. So the value will become high to tell you that it is no longer clean. Okay, so let's Move. Go forward. Go forward. Go forward. Yes. Sorry, this is not clear. But this is a screenshot of the kind of data that this thing uploads to the cloud. And then, yes, this is the cloud platform called ThinkSpeak. This is where we monitor in real time the performances of each of the sensors, the 6 of them. At any minute, we can know what is happening in the pond, irrespective of our location. And then we can decide to download the data set to do whatever we want to do with it. And then, between June 2021, when we fully deployed, till date, we've been able to gather over 2 million data sets from the pond, because almost in less than, within a minute, it uploads the data set to the cloud. And then we provided here the link where we have, this data set is licensed already, and it has a DOI information. So if you go to this link at Cargo's repository, you will be able to see the upload that we have made. The upload includes also, apart from this sensor detail, we also captured the length of the fish and the weight of the fish on daily basis. You understand? So all these things are there. So that with that, you will be able to predict what length your fish will be in 3 months, what weight it will be if these inputs are in order. I hope you understand. All right. So this is the summary of one of the data sets. I don't know if you can see very well, but you can see there's temperature there, there's turbidity, there's DO, there's pH, and so on and so forth. For instance, when you come across this data set, the speaker, director of ICT, mentioned that IoTs have their own challenges. Sometimes some of these components malfunction, and then we'll have to place somebody on continuous maintenance of this. So sometimes they can read negative value. It means that something is wrong. So if you're able to see, you will see that there are some negative values which showed you that was because it has minimum value, maximum value, mean, median, and all that. So anytime you see a negative value, you know that something went wrong at that point in time. So this is a typical one. Like this is for one of the ponds, and the stocking density of this pond was 50 fishes. And at this time we took the reading. The maximum weight of the fish was 972 grams, which is almost 1 kg. This was around October or thereabout. So these are the kind of things you will likely see. And then regressing this data, we found out that this data is statistically significant. Here we did a regression trying to predict, and we got an accuracy of 91%, showing, and then if you look at the side there, you will see that the p-values show that they are statistically significant, which means that the assumptions made were not random. This will have been tested with confidence interval, that whatever data set you are getting is valid, is genuine, and it's accurate. In conclusion, sustainable agriculture and food agriculture. This ensures that credible data sets are generated for advisory and consultation purposes. The sensors are not very expensive. If you are interested and you want us to deploy for you, we can talk, and not a must, you must deploy all 6 sensors. You can decide the ones you want, the ones that are most important to you. So they are low cost and low-powered sensors. Most of them run at less than 5 volts. So they are not power consuming. So we've been able to do these things, and we have been able to generate data set which we have made available to the global community. And we will not say the work has finished, rather the work has just started, because we will move to the next phase, which is the phase of control. What we've just done now is monitoring. We'll move to the phase of control, where we are going to automate the whole processes, including the feeding of the fishes, that you can feed your fish from wherever you are without being physically present. You can change your water without being there. All these things are possible with IoT. So this is the next phase we are going to. Thank you very much for your attention.